Hi, everybody. I am to you after the contacts have come out. So I've got on my glasses. We're going to look at the asynchronous instructional Monday assignment and the lecture that I'm going to be doing for that. Um, and I'll just talk you through the assignment, which I've got up here on another screen. So basically, what I'll do is we'll look at the assignment and then I will help you see what we're trying to do with this assignment and then switch into Excel and walk you through it. So let's start with sharing the screen where I have the assignment pulled up. And that's where we are over here. So I'll be looking that way. You can see that what I want to do is take the production and cost tables that we saw today in class and see how to convert those into the graphs that we drew. So I want you to see basically the assumptions that are underlying the shapes of the graphs that we drew in class. And so over here on the assignment, which has been uploaded into Canvas already, you can see that the purpose of the problem is to show you how we get from those tables with discrete units of output to the continuous math of the graphs that we're drawing. And so basically the idea is we're going to use Excel to do the calculations for us and to create the graphs that I showed you in class today. So let's start off with gadgets is the product that we're going to make. So it doesn't really matter what the product is. But the key is that the total cost function is given by this equation down here. And so total cost is a cubic polynomial function with a constant. And remember that variable cost then will be any portion of the cost that varies with the output quantity. So Q is the output. TC, total cost, is the total cost. And the first three terms with the Q cubed, Q squared, and Q are all part of the variable cost. Then this 200 is going to be the fixed cost. Further, for those of you who remember some calculus, you'll see that the first derivative of this function is given by this quadratic polynomial. So the marginal cost is the derivative of the total cost function. So using the power rule, the derivative of the first term is 1 over 300 q to the second power minus 2 over 5, or 2 over 10, so 1 over 5 times q plus 6. And so the marginal cost function is going to have a vertical intercept at 6 when q is equal to 0. Similarly, if we see the first three terms, excluding the plus 200 as the variable cost, and then you just divide by Q, you'll see that the average variable cost function also has a vertical intercept of 6. So again, this is reinforcing this idea that the average variable cost and the marginal cost are going to have the same vertical intercept. And here it is mathematically, all of it derived from this single total cost function. So, okay, so what are you supposed to do? We are going to use this cost function to graph first the variable, fixed, and total cost curves, and then a second graph with marginal cost, average variable cost, and average total cost. So we're going to start off making a table with Q from 0 to 100 and just calculate each of these different things that we're going to graph. So that's the plan. And I've got Excel pulled up over here. So remember that these, or pull up your version of it as you watch this, and remember that the total cost function is given by this expression. The plus 200 is the fixed cost. The rest of it is variable. This is the marginal cost. All right. So I'm going to switch the screen that I'm sharing with you and go to Excel, which is here. And so here we are in Excel, and all I'm going to do is just start off by creating the headers of the variables that we need at the top of the table. So remember that we started ours with a number of inputs and a total product. So we started with the production function. Um, I'll go ahead and put that that's equal to the total product. Oops, hit the button. So total product from that graph is now just the output quantity. And then we also need to come up with variable cost, fixed cost, and total cost, which will be the sum of those two things. And then we're going to calculate marginal cost and average variable cost and average total cost. So those are the columns that we need to create. And we're going to do this from a quantity of 0 to 100. So I'm just going to highlight, I'm going to write down 0 and 1, grab this corner down here and use it to fill all the way down to Q equals 100. All right, so we've got that done. And now I'm going to go back to the polynomial that's in the assignment and type in a formula to be equal to that. Obviously, we've got fixed costs were 200. So I'm going to fill that as well with all 200s. If you just type 200 and try to copy that, it'll count up from 200 to 201 and so on. So you put a couple of 200s in there, and then it will just copy 200s all the way down. So then we're going to do the variable cost, which we need a formula. And the Q is going to be over here in column A. So what we're going to do is have 1 over 900 times Q to the third. So Q is cell number A2. We're going to raise that to the third power. And then minus 1 over 10 times Q, which is again A2, to the, where's my caret? Second, plus 6 times A2. And of course, that's going to give us 0 right there. But I can just copy this formula all the way down, and it will fill for every value from 0 to 100. So there are my variable costs all the way. I'm going to clean it up a little bit by fixing the formatting here. There it is. Oops, let's do it this way. So we've got, then we have it kind of in dollars and cents for variable costs all the way up to 100 units, plus our 200 for fixed costs. And then total costs, you can simply add them together. You do equal E2 plus C2, and that'll give us 200. From there, I can basically copy it all the way down. A little too far. And now we've got our first graph, basically. Everything we need to put in the first graph is in there. For marginal cost, remember that's going to be the derivative of the total cost function, and it's given to you there on the sheet. It's 1 over 300 q squared minus 1/5 q plus 6. So we're going to again type a formula equals 1 over 300 times, again, it's A2 raised to the second power minus 1 over 5 times A2 plus 6. And then I can copy those all the way down as well and get the marginal cost. And then again, I'm going to, oops, I keep going the wrong way. Reduce that down to kind of dollars and cents just to make it look pretty. For average variable cost, one way to do it is to just take this variable cost measure and divide it by Q, the only problem you're going to get is that it won't work on the first row because you're dividing by 0. But if we go ahead and do that, we can say equals variable cost, which is B2 divided by A2. We're going to get that. If we copy that all the way down, it won't give us an error term the rest of the way. I'm going to replace that just by typing in 6. And then for all of these again, I'm just going to clean it up to get rid of all those extra decimals. You don't have to do this part. It just makes the spreadsheet look a little neater, and you can kind of see what's happening with marginal cost, right? Is that you can see it declining and declining and declining and declining until we get to this $3 measure here. So around 30 units, we see the bottom of the marginal cost curve and starts going back up. You can see the average continues to fall until we get to where their marginal cost is equal to 375, and the average variable cost curve bottoms out and starts going back up. So the U shape on the AVC is min point where marginal cost crosses it. With average total cost, we can do the same thing again, which is going to be take the total cost, which is on D2. I'm going to divide that by the quantity. It's going to give me an error term because I'm dividing by 0. Copy the rest of it all the way down. That's going to give me average total cost. Going to put this one in. Well, I'm actually just going to delete it. Now you can see that average total cost is really large for the first few units. And so in the instructions, I suggest maybe until you get down to around here where the ATC is about 20, which matches the kind of upper end of the marginal cost curve, we will want to just go ahead and delete those. If you leave it in at first, you'll see why. But basically, if we delete those, we'll fix the scale that Excel wants to do with the graph. And then for the rest of it, again, I'm just going to clean up the rounding so that it's only 2 digits. So effectively what we've got here are dollar values, dollar measures. Whoops, that's a mistake. There we go. I keep doing it the wrong way. All right, so let's narrow these columns down so that it all fits on my screen neatly. I'm going to do, oh, where am I looking for? Here. With that, narrow that down. So basically, I now have everything I need to be able to draw the graphs. I've created all the columns, done it just by copying the formulas. It's been very easy to do that. And you can see that again, the scale of variable, fixed, and total costs is, 20 or 30 times what you see for the other graphs. So we really want this to be 2 graphs so that you can see the shapes of the curves. And so what we're going to do is highlight the first 4 columns. So the Q, which will be on the horizontal axis, as well as variable, fixed, and total cost. I want all of those on the first graph, which is what the assignment asks you to do. So I get it all highlighted down here. And we are going to, well, gosh, I've got this stuff that's in the way. So let me make this a little smaller. I'm going to go to insert here. And what you want to pick is in charts. You're going to insert a chart, but you want a specific chart, which is this XY scatter chart. And if you have a variety of choices. So when we look at the options, you can see that you could just plot the points, right, and get a scatter. But what I suggest you do is instead of just the points themselves, do this smoothing curve. because it will go through every point, but it will also smooth out the curve. So I'm going to do that. And you can see that we've got this very nice chart that looks exactly like the graphs that we drew in class today. I'm going to move it all the way up the top so it's a little bit easier to see at the top with the top of the spreadsheet. Um, how you end up deciding to put these together and submit them is really up to you. But you can see that we've got way up here is the first chart. The chart title I'm going to say is going to be variable cost, fixed cost, and total cost. And then just to highlight the shape of it a little more, I'm going to stretch out the vertical by a bit. So and you can see then this sort of S shape where we've got an inflection point. The inflection point happens around 30, remember, was where the marginal cost changed. So we're going up, we're increasing at a decreasing rate, and then we increase at an increasing rate. Same thing happens here. So that you can see how these are starting to look closer together, even though at every point they are the same distance apart, which is the 200. So you can see it more clearly here than certainly what I drew in class today because I'm not a very good artist. All right, so that's the first of the graphs you want to draw. You can see that it's labeled down here, so you're just going to eventually take this, cut and paste it into probably a Word document is the easiest thing. Paste this graph, and then the next one we're going to draw. The next one we want to draw a graph's quantity on the horizontal axis, just like here, and we're going to graph it against marginal cost, average variable, and average total. Now, the easiest way to do that is just to graph the whole thing again like we just did, but for the whole table, and then just delete the couple of graphs that we don't want in there. So I, again, just have the whole table highlighted. I'm going to go back up here to insert. Let's see if can I do that over here? Yeah, there's insert clearly visible here. So we insert, again, the XY scatter chart and pick the smooth curve and choose that. And so what it's doing, as you can see, is kind of recreating the same graph that we just did. Except down here, you can see very low something else going on. So what we're going to try to do is redo or edit this graph to get rid of the curves that are up here so you can see what remains. And so as I do that, I'm just going to click the curve and hit delete. Click the variable cost, hit delete. Click the fixed cost, hit delete. And now we have a graph that looks very much like the ones that I showed you earlier today. And again, if we stretch out the vertical, it highlights it a little bit more so that you can see that this is the average total cost curve. Here's your marginal cost curve in blue, and the purple is average variable cost. So some things to notice, right? The marginal cost curve cuts through the average variable and the average total cost at each of those curves' minimum points. The average variable cost and the marginal cost are equal to each other on the vertical axis at q equals 0. So this is meeting all the requirements. They're U-shaped curves, and the marginal cost is a more exaggerated U than the average variable. And of course, if we continued this average total cost curve, remember the values at 1 and 2 were like 200 and 100, it would again just shrink all these and make them go away. So that's why this curve literally does kind of start up in the middle of the air somewhere because it will um, it will basically chase the vertical axis asymptotically as we get closer and closer to 0. So this goes off to infinity as we get closer and closer to 0 units just by virtue of dividing by a very tiny, tiny number. All right, these are the graphs you're supposed to create. We can again change this. Oops, let's undo that. I didn't mean to delete the title. I wanted to. put marginal cost, average variable cost, average total cost. So that's what you're supposed to do. And what I want you to see is that these curves that we use for representing firm costs, and we will use them a lot in both perfect competition and monopoly chapters, right? They're all based on these tables that I showed you how to derive. And remember, the cost function is derived from a production function. But a lot of the time, what we do is we just think about the cost functions, knowing that the production function is embedded in there and the technology is embedded in the production function. So really, a cost function can adequately represent technology for our purposes in doing these models. Okay, and so you should see that we have a curve that has total costs and then average and marginal costs down here. And all of this is as we go unit by unit. Hopefully you can replicate this. Like I said, take each of these images, put it in a Word file, and probably the easiest thing to do with the Word file. So here's a Word document. I'm gonna fix yeah, we can just leave it on normal style. So basically, go back into my Excel file. You can do a Control C to copy the chart and then click on the Word file. Probably the best way to do this is paste it in as a picture. And there you go. There's the first graph. Second graph you can paste in the same way. And paste it back in here. So Control C and then paste as a picture. I guess I didn't do it right. Let's not have actually hit the Control C. Try that again. There we go. So here are the two graphs. Oh, I did get it in there before. Sorry. And then basically just highlight the whole table again. Paste that into your Word document as well. And that's your assignment. Put all that in there. Save this as a Word file. Save it as a PDF. Paste it, and then either the Word or the PDF file, upload it into Canvas, and that will take care of it. I'll go through and just verify that you've done it, and that will be the 5 points for the homework assignment. If you have counted the number of assignments, once we include this, there are 11. Remember that the total points available from homework or on the grade scale is 50, but you actually have 55 points worth of homework. So you can get more than the 50 points, which will help you a slight little bit on the overall grades. So do this thing, turn it in, and consider yourself instructed on one of the Mondays when we don't have class. That is it for me. I hope you had a good time with this, and we will stop after that. So that's it. Nope. Dang it. I didn't do any of it, did I? No, I did. Okay. We will stop recording now and